dear students, welcome to the online competitive classes from the Vidwat Academy of Science. As if you already know that you are facing the competitive examinations on the JEE Mains, NEET as well as the KSET. All are in the month of July from 18th to 31st of July 2020. Of course, you already get revised not only the first year but also the second year, at least twice or thrice in the classes that we are conducting, in the regular classes what we are conducting. But still, as if we are having nearly 1.5 to 2 months of time, again we have to revise those particular concepts in all the subjects. So that's what, again from this day itself, we are going to start the online classes with respect to which one? The competitive examinations. As if we know that the most important as well as the most important concept related to all the three branches of chemistry is some basic concepts in chemistry. Because without this background or without the basics of this, we can't have the first as well as the second year physical chemistry. In addition to that, it is more applicable for the organic analysis as well as some inorganic concept in the form of configuration also. So for that, again we are going to revise the same syllabus. That is the first topic under that we have discussed is about some basic concepts in chemistry. So you have to go through the various formulas that has been involved in the basic concepts of preferably the physical chemistry and chemical. Okay? So you go through the videos that have uploaded in the previous sessions, and also you have to know you have to make the list of formulas that will come across this particular basic concepts in preferably the physical chemistry. Okay? So let us solve some of the multiple choice questions related to this chapter. Okay? So let's start the first one. The unit of joules per Pascal is equivalent to, suppose if he mentioned SI unit, the immediately answer is itself is A without doing anything. But as if he has mentioned only the unit of that, it is to be evaluated. So first, as if we know that joules per Pascal, what is the parallel unit with respect to this? Joule, we know that it is nothing but the energy in the form of work, and that is Newton meter. Newton meter is nothing but the unit with respect to which one? Joules. Whereas Pascal is a unit of pressure. In terms of newtons, it is mentioned as Newton per meter square, as usual to the power of -1. If I simplify that, Newton meter, Newton to the power of -1, -2 to the power of -1 is +2. For that I can cancel Newton and per Newton here. Meter into meter is nothing but meter. Therefore, which one? Joule per Pascal is indirectly called as meter cube. It is also the SI unit of another physical quantity that is called as what? You have to know directly now. If it is joules per Pascal, refers to immediately which one? Meter cube, and that meter cube is the SI unit with respect to which one? The volume. Okay? So that's very simple here. Let's take the next one. A sample was weighed using two different balances. The results were calculated as 3.929 grams, and in the second case it is going to be the 4.0 grams. Then, how would the weight of that particular sample be reported? So here, which is going to be the approximate or which is going to be an exact amount is? So here, 4.0 is going to be the approximate. He has not done accurately. But as if in the first one, 3.929 grams, it is going to be done in the second balance or the first balance what has been reported here. 3.929 is going to be the exact. But due to that, you have to be very familiar with some of the rounding of the numbers. So here, as if we know that last digit round off. How to round off the last digit? It is based on three different concepts. One is greater than 5, less than 5, equal to 5. If the last digit to be round off means we have to decide what is the last one. Whether it is greater than 5 or less than 5 or it may be the equal to 5. If it is greater than 5 means then the last digit has to be increased by 1 unit. It has to be increased by what? 1. Whereas if it is less than 5, how to make that? The last digit has to remain the same without any disturbance. Suppose if it is equal to 5, we are having two different options. If the previous digit is odd itself, then it has been increased by again 1. Supposing the previous is going to be the even, the number remains the same, or the digit remains the same. So as if we are not considered 4.0 because it is just an approximate value here. For that, I have to consider only the 3.929 max. Here, what is the last digit now? 9. As if it is 9 means it is greater than 5. If it is greater than 5 means we have to round off this such that the previous digit has to be increased by 1 unit. 1. Therefore, this has to be increased by 1. Therefore, it refers to 3.9. Instead of 3, it becomes 1. Therefore, the option with respect to that one is going to be 3.93. That is, a D is the option. Why? Because as if we are having the precision and then the accuracy. We need the accuracy value. Precision is the approaching to the value, but it is the exactness is called as the accuracy. Okay? So here, as if we are not considered the 4.0 because it is just an approximate value, but which is exact here 3.929. That 3.929 can be further round off to the last digits based on the greater than 5 or less than 5 or it may be the equal to 5. So that is why we are getting the value as going to be the 3.93 has to be reported in that particular answer. That is option is D. Okay. Next is 1.0 grams of an oxide A contained 0.5 grams of the A element. In the second case, 4 grams of the another oxide of A contained 1.6 grams of the same element that is called as A. Then what that data are instance? Without working without working anything, you have to answer that. So we are having the 4 major different laws of chemical combinations. Law of conservation of which one? The mass. Total number of mass, total mass of all the reactants must be equal to total mass of all the products. For a given compound which has been formed by 2 elements, the ratio must be constant, and that is called as law of definite proportions or constant composition. If it is a multiple proportions, if I take at least how much elements? 2 elements, and we must get 2 or more different compounds, then those must be, or those 2 compounds must combine in a such way that there has to be the definite ratio in the word as multiples. Okay, so let us take this. Element is what? A. It has combined with oxygen to form, I don't know the exact formula for that. It is AO and then A. Let us call this as first and this as what? Second. Here we are having the 2 oxides of A. In the first case, he has taken 1 gram oxide, 0.5 grams of which one? A is taken. So here 1.0 grams of this. In the second case, 4 grams of the second oxide has taken 1.6 grams of this. So here, as we are having 2 elements and 2 different compounds, as if it is only one oxide or the only one compound, it is just called as law of which one? Different proportions. But as if I am taking the 2 elements and the compounds are, or the oxides of A are going to be what? 2. Therefore, it is always the Means two elements more than two compounds or two or more compounds, then it refers to which one? The multiple proportions. Okay. Next, the law of definite proportions is not applicable to the nitrogen oxide. Why? Why the law with respect to the definite proportions is not applicable with respect to which one? The nitrogen oxide. Why? So here, law of definite proportions means the individual elements that has been combined in forming a respective compound, they must maintain a constant ratio, and that is what as a definite proportions. So here, first we have to very clear, for the given element, for the what element? Given element, atomic mass is always fixed. For a given substance, or it may be the compound, indirectly called as molecules, sometimes its mm is always constant. But for the given element, or it may be the compound, both the cases, equivalent mass of element equivalent mass of the compounds are always which one? Variable. Why is variable here? Because equivalent mass depends on the valency. As we know that the nitrogen has various valencies, starting from +1 to +5. If I take an example, N2O, NO, N2O3, NO2, and then N2O4. What is that? The various oxides with respect to which one? The nitrogen. In every case, atomic mass is fixed 14, but molecular mass is also variable in case of different compounds, I must tell you. But as if the equivalent mass is also variable. Why? Because in this case the valency is +1, here it is +2, here it is +3, here it is +4, and here it is +5. Why this? Because the nitrogen equivalent mass is going to be the variable. Okay, so that is why we are saying that nitrogen atomic mass is not constant, nitrogen molecular weight is variable, nitrogen equivalent weight is variable, and then oxygen is having the atomic weight is also variable. So which is the correct option here? So why it is not applicable with respect to the definite proportions? Because the nitrogen equivalent mass is going to be what? Variable. That is why we can't apply the law of which proportions? Definite proportions. Sorry, the law of definite proportions is not applicable for with respect to which one? The nitrogen. But this is applicable for multiple proportions. Why? They must combine in a definite ratio of multiples, like 14 ones are 14 twos are 14 threes are 14 fours and 14 fives. So what that 1 to 5 refers to? Therefore, this is the concept applicable only for the law of multiple proportions, but not for the law of which proportions? Definite proportions. Okay? Next. Hydrogen combines with oxygen to form what? Water. In which 16 grams of the oxygen combines with 2 grams of hydrogen. So for how many units? Hydrogen also combines with another element that is called as carbon to form what? Methane. In which 2 grams of the hydrogen combines with the 6 grams of carbon. If the carbon and then the oxygen will combine together, then they will show in the ratio of what is to what. So how many elements we are having? 3. If it is 3 elements, it is nothing but the law of which proportions? Reciprocal proportions. Okay? Let's take hydrogen of how many grams? Hydrogen is one element of how many grams? The first case. Hydrogen can combine with not only the oxygen but also the carbon. What are the various elements here? Hydrogen combines with oxygen to form water. Hydrogen also combines with the carbon to form. Let's take first. How many grams of hydrogen in the first case? 2 grams combines with 2 grams of hydrogen combines with how many grams of oxygen? 16 grams of oxygen. Means in what ratio they are combining. It is called as law of definite proportions. It is called 2 is to 16, or indirectly I am mentioning that as 1 is to. Similarly, in the second case, what happens? Hydrogen can also combine with carbon to form methane, in which how many grams? 2 grams of hydrogen combines with 6 grams of which one? Carbon. 6 grams of which one? Carbon. Means they are in the ratio of 2 is to 6, or it may be the 1 is to 1 is to 3. In what ratio they has to combine? They has to combine in the ratio of which and which? Carbon and oxygen. Here has mentioned that carbon and oxygen, they has to combine in the ratio of 6 is to 16. If I simplify that, if I enlarge that, it becomes without solving anything, you have to get an answer. Because as in the time is very precious to your competitive sessions and competitive examinations. As in how many elements are there? 3 elements. 3 elements separately refers to which one? The law of reciprocal proportions. 2 elements, only one component is law of different proportions. 2 elements with at least 2 or more different components, then it is called as law of multiple proportions. Suppose total mass of all the reactants must be equal to total mass of all the products, then it refers to law of conservation of mass, or indirectly law of conservation of matter also. Okay, hydrogen, carbon and oxygen. Hydrogen combines with oxygen to form what are in the ratio of 2 is to 16 or 1 is to 8. The same element hydrogen combines with carbon to form methane in the ratio of 2 is to 6 or 1 is to 3. Then what happens when carbon also combines with oxygen? They form carbon dioxide. In what ratio? They must be the ratio of either 6 is to 16, or it may be 12 is to what? 32. Therefore, the option with respect to this one is A. Okay. Next, when 100 ml of 1 molar in solution and 100 ml of 10 normal H2SO4 solutions are mixed, the resulting solution will be what? Usually major students, what they do the mistake in this particular type of question is, as NaOH is a base, as H2SO4 is a acid. What happens when acid reacts with base? They form salt. Immediately they will write the answer as neutral. Of course, in this question it may be neutral, but how we are getting that neutrality? For complete neutralization, the important concept, for complete which one? Neutralizations. Number of gram equivalents of acid is equal to number of gram equivalents of base. GEA is what? Gram equivalents of acid. And this is number of gram equivalents of GE, which gram equivalents of base. How do you have a number of gram equivalents of base? It is NV by 1000 of acid. NV by 1000 of base. This is the formula for the calculation of this one. Number of gram equivalents of either acid or it may be the base. It is the product of normality into volume divided by what? 1000. Let's take the first. What's the normality of the acid that has been taken here? It is 10 normal into volume of H2SO4 is this divided by 1000. Let's have that. What's the normality of base? Base is sodium hydroxide. Here, you have to be very familiar. Normality is equal to molarity into acidity. What is acidity? Number of OH minus ions. How many OH minus ions are present in NaOH? Only 1. Therefore, if this is equal to 1, then which must be equal to which? Normality must be equal to which one? Molarity. So let's have the normality or molarity for NaOH here it is 1 into what's the volume occupied by that? It is 100. Can you see that both are same? 100 by 1000 or 1 by 10. As the number of gram equivalents of an acid is exactly equal to the number of gram equivalents of a base, it is a perfect neutral substance called as salt. Okay? Suppose if the number of gram equivalents of acid is greater than then it refers to acidic nature. If it is less than, then it is found to be the basic. If it is very much greater, then it is more acidic. If it is very much lesser, then it is more basic. This is how we are going to decide whether the solution is going to be a neutral or an acidic, or it may be the basic, or strongly acidic, or it may be the strongly basic. That's the main concept here. It is number of gram equivalents of any acid must be equal to number of gram equivalents of a base if it is to be a perfect neutralization or a complete neutralization. Okay, next. For preparing 0.1 normal solution of a compound from its impure sample in which the percentage purity is found to be the known, then the weight of that particular substance required will be what? Here we have taken the impure sample of the substance. If I take the impure sample of the substance, means the solution is impure and the concentration. One thing you should be very clear: presence of impurity in the given sample decreases the amount of a which one is solute. W2 is amount of a solute, and hence decreases the which one? Concentration of that particular solution. If it is impure, the presence of any impurity in the given sample always increases the number of moles of solute. W2 is number of moles of solute, and hence it decreases the which one? Concentration. But to get an exact concentration of 0.1 means first I am getting less than this, because the solution concentration is 0.1, means I am getting less than this. How to have this exactly equal to 0.1? How the concentration of any substance is increased? By increasing the mass of solute. Because why the concentration gets decreased? Because of the presence of impurity. What the impurity will do here? It will decrease the amount of which one? Solute. If it decreases the amount of a solute, means it decreases the concentration. But to get how much normality? 0.1 normal. As in the normality is constant, but I am getting due to the impurity it is less than 0.1. To get the exact of this, just you increase the mass of that particular cell. Therefore, it is more than the which one? Theoretical weight. Why? Because the sample is highly impure. So get a pure sample of that, just you increase the mass of that particular solute, that is called as W2. Okay? Next. What is the concentration of the nitrate ions if equal volumes of which are taken? 0.1 molar of silver nitrate and 0.1 molar of sodium chloride solutions are mixed together. Here, what reacts with what here according to that particular MCQ? Silver nitrate made to react with sodium chloride to form. We know that it is the best example for a double decomposition reaction, or it is the best example for a precipitation reaction. So here it forms NaNO3 plus AgCl in the form of precipitate. It is aqueous. So here it is taken 0.1 molar, here it is taken 0.1 molar. Just here has the concentration of what? Nitrate ions. So no doubt here also initially it is 0 and 0. If it is 0.1, here it is also 0.1, here it is also 0.1, and here also it is 0.1. But as in this, the left is 0, 0, 0.1 molar and then 0.1. As if it is in the form of precipitate, we are neglecting the silver chloride. But here, what's the meaning of molar? Means mole per dm. What's the meaning of this mole per dm? Means this is the concentration 0.1 mole per 2 dm. Why? Because it is a mixture. Therefore, it is equal to 0.05 mole of or per dm cube of Na, which also contains Na plus ions and then the NO3 minus. Because first they must be in the ratio of what is to what is to what is to what? 1 is to 1 is to 1 is to 1. Here, NaNO3 is also in the ratio of what is to what? 1 is to 1. If 0.05 mole per dm cube is the concentration of sodium nitrate, means it is having the same concentration for the either the nitrate ions or maybe the what ions? Sodium ions. But here it has asked only the what? The concentration of what ions? Nitrate ions. Hence the value for this one is going to be 0.05. Okay. Next. 74.5 grams of the metallic chloride contains how much? 35.5 grams of chlorine. Then what should be the equivalent weight of that particular metal? As in the theoretical part, when we are discussing about the equivalent mass of a substance can be determined by 4 different methods called as chloride method, oxide method, hydrogen displacement method, and then the interconversion method. Okay? So by seeing that particular MCQ on the question, we are deciding it is the chlorine. Therefore, the name of that method is called as what method? Chlorine. Equivalent mass of the metal is equal to. What is the equivalent mass of metal? By what method here? The name of this method is called as chloride method. What method here? Chloride method. W of M divided by W of Cl into 35. This is the formula for the calculation of what mass? Equivalent mass of a metal by what method? Chloride. That's it. So here, what is MCl mass? 74.5 grams. This contains 35.5 grams of chlorine. Then what must be the mass of chlorine here? Metal chloride is this. Chlorine is this means it is MCl minus Cl. That is equal to 74.5 minus 35.5. If I simplify that, it becomes 39. What is 39? It is the mass of the which one? So don't waste this much of time during the calculation. As if we are having a restricted time. Okay? Immediately see the mass of metal chloride, mass of the chlorine, that difference of these two gives mass of the metal. Okay? So what is the mass of the metal here? It is 13. What is the mass of chlorine that has been present here? 35.5. Into standard is cancelling these two here. What material is? It is the which mass? Equivalent mass of the element that is called as. This method is called as chloride method for the determination of equivalent mass. Suppose it is oxide method. Mass of the metal divided by mass of oxygen into equivalent mass is 8. If it is hydrogen, mass of the metal divided by mass of hydrogen into 1.008. That's the difference between the chloride method, oxide method, and then the hydrogen displacement method. Okay? Next. 3.75 grams of a gas occupies 2.8 milliliters of a volume at what? ST. Then what is the name of that particular gas? So you have to be very familiar with what is molar volume first. What is molar volume? Molar volume is the volume occupied by 1 mole of what? Gas at ST. Any gas existing in nature, for how many moles? 1. What is the respective volume at standard temperature and pressure refers to what? So here, this refers to 22,400, or in terms of liters, I think, it is 22.4 liters. 1 mole always refers to mm. What is mm? Molecular mass. In particular, it is GMM, that is called as gram molecular mass. Okay? Means, how much he has taken first? 2.8 liters at STP occupies 3 point how many grams? 75 grams. Therefore, for 1 mole to get what mass? Molecular mass. It is 22.4. 22.4 into 3.75 divided by So not 28, it is 22.8. Can I write this as 224 into 3.75 divided by 20? Just multiply this by 10, multiply this by 7 fours, I think. 7 threes are. 1 left, 1 means it is 2. 4 ones are 4 eights are. 3.75 double is 7.5. That double is 50. That double is, because addition is 8 times. That is equal to. So what it is? It is the gram molecular mass. Why it is gram molecular mass? It is the volume occupied by how much? 1 mole. What is mean 1 mole? 22.4 liters. So now that which is fit for the 30 as a molecular mass. I think most of this one. Why? N is 14, oxygen is 16, therefore it is this one. There it is higher. This is 28, I think, and that is 44. But we need only the 30. Therefore, the volume occupied by the nitric oxide for a mass of 3.75 grams under 2.8 refers to it is only the nitric oxide. Okay. The equivalent mass are weight of an element is going to be the what? 4. Its chloride has a vapor density of 59 point how much? 25. Then what should be the valency of that particular? He has given the equivalent mass. Vapor density of the chloride, then what is the equivalent? So the valency of that particular element. So here, as if we know that for element, atomic mass is equal to equivalent mass into respective valency of that particular element. For a compound, if it is a compound, mm is equal to em of this particular compound into valency of that particular element. Make a clear distinction between whether it is an element or it is a compound here. Because as if it is a chloride means it is a compound. But he has mentioned only the equal mass of that particular element is going to be the 4. Also, we know that 2 into VD, molecular mass is always equal to what? Twice the what? Twice the what density? Vapor density. Therefore, I have to get valency. What is valency is equal to? 2VD divided by equal mass of the given compound. Here, what is the compound here? Chloride means MCl, the compound is respective chloride gas mentioned. 2 in. What is the vapor density given? 59.25 divided by. What is the equal mass of this one? It is an equal mass of M plus equal mass of chloride. Equal mass. So here, for the compound, preferably the metallic chloride, because it is a chloride of that particular element. Let us call that as metallic chloride. It is equal to the equal mass of that compound in respect to which one? Valency. Here, valency is nothing but what? 2 into what density? Vapor density divided by the equal mass of the compound. 2 into vapor density is going to be 59 point how much? 25. And equal mass of the metal plus equal mass of the chlorine, because equal mass of any compound is equal to the sum of the equal mass of the individual elements. Here, according to that, the equal mass of element is going to be what? 4. And the equal mass of the chlorine, we have to know that it is a standard, it is 35.5. If it is oxygen 8, if it is hydrogen 1. Okay? So if I simplify that, it becomes 39.5. 118 divided by 18.5 divided by 39.5 refers to 3. What that 3 is? It is the equal mass of the element in the respective chloride of that element. Okay? Next. 1.25 grams of a substance or a solid substance, preferably it is a dilithium acid, is completely neutralized by what? 25 ml of 0.25 molars barium hydroxide solution. Then what must be the molecular mass of that particular acid? As if I mentioned earlier, what is the main condition for the complete neutralization? Because as the neutralization is between an acid and then the base. With the acid here, it is a dilithium acid. What is the base here? It is barium hydroxide. What is the condition? Number of GEA is equal to number of GeV. What's that? Number of gram equivalents of an acid is always equal to number of gram equivalents of a base. For what purpose? Complete neutralization. How you have calculated the number of gram equivalents? In two different. One is normality into volume divided by 1000 is one formula, and if mass is given, it is E divided by W divided by E of acid is equal to N into P by 1000 of the base. Why I taken W by E for a number of gram equivalents? Because it is in mass is given. If mass is given, it is mass divided by which mass? Equivalent mass. That is equal to, if it is in volume and molarity or normality, it is in normality into volume divided by. So here what is the mass of the acid that you have taken? 1.5. Equivalent mass of the acid that I have to find is equal. What's the normality here? We know that normality is equal to molarity into base, means it is called as acidity. Here what's our base here? Barium hydroxide. Barium is bivalent and hydroxide is monovalent. Therefore the formula for this one is Ba. What's its acidity? It is, what's the molarity given? 0.25. If I simplify it, becomes 0.5. What 0.5 is the normality of the base. Into what is its volume? It has taken 25 divided by 1000. Okay? So let us have the simplification of this. Therefore, what is EA first? EA is equal to multiplication of these two can directly write as 1250, 1250. 0.5 into this one is actually 12.5. 12.5 into 100 is actually 12,250. Okay? It is the equal mass of the acid. What he has as the mm of the acid. Mm of the acid is equal to EM of the acid into basicity. If it is base, it is called as acidity, number of OH molecules. If it is an acid, it is called as what? Basicity. Basicity means number of H plus ions. As itself, it is mentioned as a dibasic acid. Dibasic acid means basicity is how much? 2. So it is 100 into how much? 200 is equal to. What 200 refers to here? It is the which mass? Molecular mass of the acid that is equal to. Okay? So the condition is for any complete neutralization, what happens here? The number of gram equivalents of an acid is always equal to what? Number of gram equivalents of a base. But we have to calculate that number of gram equivalents under two different concepts. If mass is given, it is mass divided by which mass? Equal mass. Suppose if volume and concentrations are given, it is given by normality into volume divided by. Okay. Next, assuming fully decomposed, the volume of carbon dioxide that has been released at STP on heating 9.85 grams of which carbonate? Barium carbonate. This one clue is given. The atomic mass of barium is going to be 100. Decomposition of this substance here, barium carbonate. What happens when barium carbonate gets decomposed? Barium carbonate is similar to that of calcium carbonate. On decomposition at what? STP. We know that calcium carbonate gives rise to calcium oxide plus carbon dioxide. Similarly, barium carbonate decomposed to form barium oxide along with carbon dioxide. Here, 1 mole of barium carbonate is equivalent to 1 mole of carbon dioxide, because he has related the barium carbonate with which one? Carbon dioxide. Now, barium carbonate is expressed in terms of mass because it is 9.87. What is 1 mole of this one? It is called as a GMM. What is GMM? Gram molecular mass. What is the molecular mass of carbon? So atomic mass of carbon here is 137. Carbon is 12. Oxygen is 16. 16 3 is 48. 48 plus 12, 60. 60 plus 137. It is equal to. What is 187 here? It is the gram molecular mass of which carbonate? Barium. Carbon dioxide has mentioned, or he has to express that in volume. What is 1 mole of any acid STP? It is 22 point how much? 4 liters. Means how many grams is equal to how many volume of carbon dioxide? Here 197 grams of barium carbonate is equivalent to 22.4 liters of which one? Carbon dioxide. Because it is standard. This is called as gram molecular mass and that is called as molar volume. But he has asked for how much? 9.85 grams is equal to how much? 9.85 into 22.4 divided by 197. So assume that it is almost 10. Here it is 200. Means 1 zam 22.4 divided by 2 is actually 11.2, but it is 20 means it is found to be the 1.12 liters of which dioxide. Therefore, what is the volume here? It is 1.12 liters of carbon dioxide is liberated by the decomposition of how many grams? First, standard is 197 grams of barium carbonate on decomposition at STP gives how much liters? 22.4 liters of carbon dioxide. But for 9.85 grams of the same barium carbonate, it has to give how much? 1.12 liters of carbon dioxide. Okay, next. Rearrange the following 1 to 4 in the increasing order or in the order of increasing masses and choose the correct answer from A to B or A, B, C, D. Atomic masses all are given 14, 16 and 63 for nitrogen, oxygen and copper. Here, one molecule of which one? Carbon, sorry, oxygen. One atom of which one? Nitrogen. Then 1 into 10 to the power of minus 10 grams of molecular weight of oxygen, and finally 1.1 10 to the power of minus 10 gram atomic mass of which one? Carbon. Let's say first. One molecule of oxygen. What is mass of one molecule of oxygen? Oxygen is an atom. Sorry, oxygen is a molecule. How do you get mass of a single molecule? It is GMM by NA. The mass of how many molecules? One molecule is always equal to the gram molecular mass divided by what number? However, I think 22 is the molecular mass of which one? Oxygen divided by 6 approximately 10 to the power. Don't simplify this. The second case is mass of one atom of which element? Nitrogen. Nitrogen actually it is a molecule, but he has specified that. That's why it is the not the molecular mass, it is the GAM. What is GAM? Atomic mass. Gram mass. Divided by what number? What's atomic mass? By our number is, don't simplify that. Okay? The third one is 1 10 to the power of minus 10 gram molecular weight of which one? Oxygen. Gram molecular weight. Gram molecular weight is nothing but gram molecular mass also. Means 1 into 10 to the power of minus 10 into what's the gram molecular mass or weight of oxygen? It is 30. Next, last. 1 into 10 to the power of minus 10 gram atomic mass of which one? Copper. It is nothing but GAM. What's GAM? Gram atomic mass. That is 1 into 10 to the power of minus 10 into what's atomic mass of copper he has given. Don't simplify this first. Can we say that these two are greater compared to these two? Why? Because it is in the 10 to the power of minus 10, 10 to the power of minus 10. Here it is. If I shift to the numerator, it becomes minus 23. Therefore, third and fourth are greater compared to that of which one? Third and fourth are greater compared to that of which one? Which? 1 and next among these two, which is greater here? 32 or 63. Here it is. Fourth is greater than first, third. Next, among these two, numerator higher value because denominator is constant. Means higher the numerator value, more is the net answer. So here, first is greater than second. Next one. 520 grams of a hydroxide of a metal on ignition. Ignition means it is on complete heat. Gives 0.995 grams of its oxide. Therefore, what is the equivalent mass of that particular metal? Here first, what is a reaction now? What compound on ignition gives what compound here? That is the meaning. Hydroxide of a metal. Can I say this young OH for example? It's not exact, but it is a metal hydroxide. On ignition is on strong heating. What it is? Oxide of the metal means it is this along the liberation of, I think most of it is a clear. I have mentioned there are 4 different methods to determine the equivalent mass of an element. Either it is a chloride method, or the oxide method, or the hydrogen displacement method, or the interconversion method. Here what is this? Interconversion means metal hydroxide is connected to metal oxide. For that you have to be familiar with the formula. Mass of metal hydroxide divided by mass of metal oxide is equal to equivalent mass of metal hydroxide divided by equivalent mass of the same concept that we are using in the Faraday's second law of electrolysis. Because as if the same quantity of electricity is passed through the 2 or more different electronic solutions, then the mass of the individual substances deposited is always respective to their respective what masses? Equal masses. But here is an interconversion. So can I say that it is equal mass of M plus equal mass of OH minus equal mass of M plus equal mass of O2 minus. That is, you have to be very familiar. Hydroxide is OH minus, oxide is O2 minus. What is this? 1 point. What's the mass of this one? 1.520 divided by what's the mass of the metal oxide? 0.995 is equal to equal mass of the metal is not known plus OH minus equal mass of the ion is formula mass divided by valency. What's the formula mass? Oxygen is 16, hydrogen is 1, 17 divided by valency is 1, therefore it is equal to 7. Equal mass of the metal is not known. He, oxide, oxygen is 16 divided by valency is 2, therefore it is equal to. Okay, so I think, can I say that it is nearly 3 by 2? Approximately, I am not exact, because as if in the examinations they don't provide any calculators. For that we have to make, assume that it is 1.5, this is nearly equal to 1. What is it? 1.5 divided by this is 3 by 2. Therefore, so here it is 3 into E plus 8 is equal to 2 into E plus 17. 3e plus 24 I think is equal to 2e plus 34. Difference of those two. 3e minus 2 is e, that is equal to r. E is equal to what? But I am not getting the value of 10 and those options. But which is very nearest to that 10. I think it is. Why am I getting the answer is 10, but the exact answer is going to be the 9. So here the thing is, it is an approximation because as if I didn't have any calculators or any longitudinals for that. For that, I have made an approximation. Instead of 1.520, I mentioned 1.5 and 0.995 is nearly equal to what? 1. Therefore, it is 1.5 divided by 1 is equal to what by what? 3 by 2. Based on that approximation, I am getting the value is what? 10. But if you know that, it is always greater than 3.5. If this is greater than 3.5 means it is less than 10. Less than 10 means it is going to be done. So this is how you have to be. You have to calculate to an approximation to get the exact. Okay. Next. Ratio of Cp by Cv are Cp and Cv means what? They are the molar heat capacities at constant volume and then molar heat capacity at constant pressure, constant volume. Of a gas is found to be the 1.4. Number of atoms of that particular gas present in 11.2 liters of it at LPB. So what is Cp by Cv? It is called as Cp by Cv. Depending upon the value of what? Cp by Cv. This is called as Poisson's ratio. 1.4, it is diatomic. If it is 1.6, it is monatomic. If it is 1.33, means it is triatomic. But as if the value is going to be 1.4, what it is? It is an example for A. Means, no doubt, the formula for that one is going to be the X2. So here he has mentioned 11.2 liters at STP refers to, can you say this half mole of X2? Why? 22.4 liters is 1 mole of a gas. What's the name of the gas here? It is not X, it is X2. Why? Because based on the value of 1.4, which is going to be the water atomic. Therefore, 11.2 liters of that gas at STP is nothing but what? Half mole of. That is equal to Na number of X2 in terms of molecules. It is Avogadro number. But yes, as not for the number of molecules, only the number of atoms in it. Can I say that it is equal to 2 times the Na of X atoms? Why? Because it is again what atomic? Diatomic. That is equal to 2 into Avogadro number of, sorry, half the number. Half the N number of which molecules is 1. Half into 2 is N number of what atoms? X atoms. Therefore, 6.022 into 10 to the power of 23. Means 11.2 liters of that gas is going to be the half mole of the gas. Half mole of the gas is nothing but half the number of Avogadro number of the molecules. But how the molecules are converted to atoms? Based on its atomicity. What is the atomicity here? It is 2. Based on the value of what? Cp by Cv is equal to 1.4. Okay? So the option with respect to that is 6 into 10 to the power of 6.02 into 10 to the power of 20. Okay? A gaseous mixture contains methane and ethane in equimolar proportions. Therefore, the mass of 2.24 liters of that particular mixture at STP or NTP is how much? Both STP and NTP are same. That is normal temperature and pressure or standard temperature and pressure. As the temperature is constant and the pressure is constant by Avogadro's law, equal volumes are always equal to equal number of moles are equimolar. It is a statement given by what? Avogadro's law. At constant temperature and pressure, equal volumes of all the gases always contains equal number of moles are it may be the molecules. Okay? So here, the volume of methane plus volume of ethane is equal to I think 2.24 liters. Therefore, what is volume of methane here? Volume of ethane, that is equal to 2.24 divided by 2, that is equal to 1.12 liters. Why? As if both are what polar? Equimolar. Means they must have the what volume? The sum of those two is going to be how much? 2.24. Therefore, individually they must have the half of the volume, that is 2.24 divided by 2, that is equal to what? 1.12 liters. Next. What is 22.4 liters of methane refers to? Can you say it's 1 mole? And respective mass is called as molecular mass. Therefore, it is 16 grams, right? 22.4 liters is molar volume of 1 mole, and the respective mass is compounded with the GMM. What is that? Gram molecular mass, that is equal to 16. Therefore, what is the volume of this? 1.12 into 16 divided by 22.4. So you are having some relative. 1s are 20s are. 4s are 5s are. 4 by 5 is what is 0.8? It is the mass of which one? Methane, which occupies how much liters? 1.12 liters. Let's have another one. 22.4 liters of ethane is having a mass of, again it is 1 mole. Ethane, it refers to 30 grams. It's 30. It's a GM. Gram molecular mass. 12 2s are 24. Plus 1 6 are 6. 6 plus 24, that is equal to 30. But what is the volume here? 1.12 liters. 1.12 into 30 divided by 22.4. Again, 1s are 20s are 0 0. 3 by 2 is 1.5 grams. What is the individual mass here? It is a 0.84 grams for methane and 1.5 grams of ethane. But the mass of that mixture, what is the mass of this mixture here? Addition of these two, what is 1.5 plus 0.8? Therefore, the option with respect to this is 2 point. What is 2.3? It is the mass of both the which and which? Methane and then ethane, and occupying a total volume of how much? 2 point. As if it is of equal molar, each have the same volume or a different volume. It is the same volume according to the statement given by Avogadro's laws of hypothesis. Okay, next. Vapor density. Vapor density of the metal chloride is found to be the 66. Its oxide contains 53% of the metal. Therefore, what is the atomic mass of that particular metal? Here we are having two conversions. One is an oxide method as well as a what? Chloride. Because vapor density of metal chloride is given, but the oxide of the metal contains 53% is given. Therefore, what is the atomic mass of that particular? Now, let us have first the equal mass of the metal. Equal mass of the metal is equal to mass of metal divided by mass of oxygen into, because as I discussed, the oxide. What's the mass of the metal here? Here, MO is 100%, assuming. Therefore, M is 53. Therefore, oxygen is 47. Okay? In terms of percentage, mass of the total compound that is called metal oxide is 100. Among that, what is the percentage of the metal given? It is 53. If the mass of the metal is 53, which what is the mass of the oxide that has been taken? It is 100 minus 53, that is equal to 47. Okay? Mass of the metal is 53 divided by what is the mass of the oxide? It is 47 into. Go to the rough calculation. There is no need of that. Okay? 1 are, can I say that approximately 8 are here? So 6 are. 8 6 are 48. But here it is 6 ones are nearly 9. 9 6 are 50. Means the approximate valence equivalent mass is going to be the what? 9. Next. Vapor density of the metal chloride is 66. Therefore, what is the atomic mass of that metal? So how to calculate if the vapor density is given? As if I mentioned that valency is given by mm by equal mass of the MCl. MC? Yeah. That is equal to 2 into what? Vapor density divided by equal mass of the metal plus equal mass of the chloride. Because that is the chloride. 2 into what is the vapor density given? 66 divided by what is the equal mass of the metal that I calculated? 9 plus. What is the equal mass of the chlorine that I have taken? It is going to be the 35 point. 35 point. Equivalent mass of the chloride is equal to equivalent mass of that particular chloride 2 into vapor density first. Molecular mass is equal to valency into equivalent mass of that particular compound. Therefore, it is 2 into vapor density is how much? 66. 66 divided by 9 into, sorry, what is 9 actually? The equivalent mass of the metal plus equivalent mass of the chlorine is going to be the 35. And then get the value with respect to the valency of that particular element. Okay? So what must be the value for that? It is 72, I think. It is, sorry, not 72, 132. 130 divided by 30, sorry, 44.5. 44.5. It's an approximation here. Assume that it is nearly 45. 45 2s are 90, 45 3s are 135. Here it is actually 2 point something, but 2.9 something. But valency is always say what number? Whole number. Therefore, the valency is going to be the what? 3 first. But he has mentioned what is atomic mass is equal to? It is the equivalent mass into what? Equivalent mass is 9 and this is equal to this and that is equal to what 27 is the 27 is the which mass? Atomic mass. So here we are having the 3 different conversions. First, from the oxide of that we have calculated the what mass? Equivalent mass. Equivalent mass of a metal is given by mass of the metal divided by mass of oxide into how much? 8. On that basis I get the result as nearly 9. It's not exactly an approximation. Then, how to find the valency of that element? As it is from the chloride. If that be the case, it is the molecular mass divided by equal mass of that particular metal chloride. We know that molecular mass is equal to twice into what density? Vapor density. Therefore, 2 into vapor density. And equal mass of any compound is equal to the sum of the which masses? Equal masses. What are the equal masses here? Equal mass of metal and then the equal mass of chlorine. What's the equal mass of metal that I calculated here? Is 9. Equal mass of chlorine is only 35.5. On simplification, I will get the nearest value as 3. Then how to calculate the atomic mass? It is the product of equal mass with respect to which one? Okay. Next. 100 ml of phosphine. 100 ml of which one? Phosphine. Produce, on decomposition produces phosphorus and then the hydrogen. What is the change in that? What is decomposition here? Phosphine. First, phosphine is pH 3. On decomposition means upon heating, we are getting phosphorus and hydrogen. Phosphorus and hydrogen. Phosphorus is solid, hydrogen is gas. Phosphine is also a gas. Balance first. 2 here. 2 phosphorus. Here it is. Means if I take this 2 moles, I am getting 1 mole of this. Sorry, 2 mole of phosphorus and 3 moles of which one? Hydrogen. Suppose if I take 100 ml of this, I am not getting this. Why? Because volume. As if it is a solid means I don't take the volume of that particular solid. As if phosphine and hydrogen they are in the ratio of what is to water? 2 is to 3. If this is 100 means it is 150. Because the amount of the phosphine decomposed is with respect to hydrogen they are in the ratio of 2 is to what? 3. Suppose if it is 100 means it is no doubt it is. Means 2 to 3 means 100 refers to what? A simple calculation. 100 into 3 divided by 2 that is equal to 100. What is 150? It is direction. But he has asked you what is change in volume? Change in volume is delta V is equal to V2 minus V1. This is V1 and this is V2. It is 150 minus 50 that is equal to plus 100. Sorry, 100 plus 50. If it is plus 50 means it is increase. Without doing that 100 becomes 150 means there is an increase in the which one? How much? 100 ml of phosphine on decomposition gives which and which? Phosphorus and then the hydrogen. The net increase in the volume or change in the volume is not going to be done. Okay? Next. On reduction with hydrogen, 3.6 grams of an oxide of the metal left. 3.2 grams of the metal. If the vapor density of that particular metal is going to be the how much? 30. What is the simplest formula of that particular oxide? Reduction with hydrogen 3.6 grams of oxide of a metal. Oxide of a metal means MO. On reduction with which one? Hydrogen. It gives metal plus water. This is the reaction. What's the mass of the metal oxide that has been taken here? 3.6 grams. What's the mass of the metal that has been obtained? It is mass of the metal is going to be the 3.2 grams. Vapor density of that particular metal is going to be the 30. So then what should be the simplest formula of the oxide of that particular element? So here, as it is an oxide metal, equal mass of M is equal to W of M divided by W of O into what's the mass of the metal? 3. What's the mass of the oxide? Mass of metal oxide is 3.6. Mass of the metal is 3.2. Means the difference of these two gives the mass of oxide. What is 3.6 minus 3.2? That is equal to into 1 sum 0.4. 4 1s are 4 8s are. It is equal to 60. What 64 is? It is the equal mass of the metal. In the second case, density in the metal is found to be the 32, then what should be the simplest one? Valency, we know that it is equal to twice the vapor density divided by equal mass of that particular compound. That's equal. 2 into, what is the vapor density given? 32. Divided by equal mass is going to be the 16. That is equal to. Valency of M, metal M is in plus 1. M is having a valency of what? 1. Oxygen is minus 2. Plus 1 minus 2 is not equal to 0. Convert that into 0. Can you multiply this by 2? Therefore, the formula for that one is on what basis here? First, we have calculated the equal mass of the metal, because what is converted to what here? Metal oxide is converted to metal by the reduction using which gas? Hydrogen gas. Based on that, I am getting the equal mass. Then, how do you valency? It is the twice the vapor density of that particular element divided by equal mass of that particular element. On simplification, means valence is equal to 1 means you always mention that the equal mass is always equal to the molar mass. If valence is equal to 1 means metal is having a plus 1.